Hey, hi, Marconi.
Hey, hey, what's up? Um, sorry, Saksham, is the YouTube link not working at the moment?
Yeah, it is working. We are just about to start the stream there. Yeah,
Okay,
it is
sure.
active there.
Yeah, sure.
Yeah,
Just making sure because that's the one that I shared with on
yeah,
our socials. All right, that's
yeah,
good.
yeah, it is active. We will just starting in just a few minutes.
Sure, that's good.
Hello everyone. Am I audible and visible?
Yeah,
So hello, my name is Vishu Bansal, your host for today, and I welcome to you all in this amazing webinar on DevOps, one of the most highly paying industry level skill. DevOps is the technology which one can definitely try out if you are a developer because it makes the workflow very smooth and easy. It combines both software development and IT operation, and it makes the work easy for you. Although the technology at first may appear very overwhelming to learn. So to bring us more light on this topic, we have today with us Mr. Dinesh sir, a member of KodeKloud, one of the most and effective and best training platform for DevOps. He has done some amazing work in the DevOps community and is continuing to do so by helping many students worldwide, creating the industry's most effective and celebrated hands-on lab experience, which combines gamification and transformation learning. He is CK, CCAD, KCNA, Terraform certified, and holds an extensive knowledge in the different tool sets for that are required for DevOps technologies like Linux, Kubernetes, Docker, SCM, CI/CD, and many others. So, with that being said, I would like to give the spot to Dinesh sir. Hello, Dinesh sir.
hey, thanks, Vishnu, yeah, for introducing me. So I would like to take this opportunity just to, yeah, thank you, and yeah, I'm very glad and very excited for this collaboration. I have been waiting for this like for so long. So I've, yeah, so I will just get on with the presentation, and if it's all right with you, just let me know if any other thing is like in the way. Vishnu.
No, no, everything is fine.
Okay, so I will like just without any further delay, I will like to start if that's okay. So
Yes.
yeah, just let me know when my screen is visible, right? Yeah, so is it visible?
Yes, 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 it is.
Yeah. So yeah, once again, thanks Vishnu for introducing myself. So
Yep.
I will, yeah, I will like to, take just for once again a quick note about me, and I will try to keep it as short as possible because you have already like given an overview and amazing at that, right, about me. So so a quick note about me. So yeah, so I am Dinesh and I am from KodeKloud, which is one of the best training platform if you're planning on learning DevOps. And I have been working at KodeKloud for quite some time now and at the capacity of DevOps engineer. And in KodeKloud, we really believe and very are passionate about to deliver the quality content to our students, which is worldwide, right? So so apart from this, I have done some recent certifications which he has told about. So among which are like Kubernetes, Kubernetes administration, and Kubernetes application developers, and few others. And make no mistake, I am still working towards more this year. So that said, I have tried to make this one interactive presentation, and for that, I just wanted you guys to have a quick, like a quick reality check about why I am presenting this, what I'm going to do, because this presentation is mostly going to be about like Docker and Kubernetes. So let's look why I am covering this topic. So I have taken the liberty to like go over the web and take and gathered certain snippets. So on the left hand side, as you can see from the Udemy report, this is the trend for adoption and the ever increasing demand for Kubernetes, right? So when compared to other contenders like even server administration or even PowerShell, they don't even come close to it. So that's why the Kubernetes in like the current tech industry standard is really booming, and that's why I wanted to cover this. So from the the Indeed report, as you can see, this is also like the current job searches, like the job structure and the kind of the skill set that employers seek in their employees, which is also without a doubt is topped by Kubernetes. So on this note, since we are going to be diving into Kubernetes, I just wanted to make sure that under the hood, Kubernetes, there are containers, and the thing that made containers possible was like so popular was Docker. So I will be like going over a quick overview about Docker, and then I will be following that up with a quick demo, and then the Kubernetes finally. So without any further delay, let's get on to this. Okay, so a quick overview of Docker. So let's start like present this slide with our favorite question: why? Why do we need Docker at all? So like as usual, we will have a machine, right? So operating system installed on the underlying hardware with its own libraries and dependencies. So let's to understand and to look to explain this, let us look at the traditional software development and delivery model. So to explain it, just suppose that we have one application. So in this application, we have four components, right? These components can be built using different languages as well as tools. So for our case scenarios, we will be looking at this Node.js, MongoDB database, and Redis messaging service, and for orchestration, Ansible. So what really happens in such an architecture? There are dependencies between the version of applications and the underlying OS system. So quite often it also happens like between these components, they have dependencies of themselves. And any changes to even one component can break these dependencies and cause application downtime. And this can become quite messy, right? So very, very messy and very complex. And there is a like a famous term for this, the matrix from hell. So the quick takeaway from this slide is like I wanted to just discuss about the compatibility and dependency issue. And since we have like we to resolve these compatibility issues, we like indulge and give a considerable amount of time to this, and that's why it like happens to have a long setup time. So this is something that developers as well as operation guys faced problems with and wanted to come up with a new thing so that we can tackle it with much more efficiency, and that's why we finally have Docker. So what Docker does, we just need to install one binary over a OS. It could be Windows or Linux for that matter. So what Docker does, it facilitates us. It facilitates us to like encapsulate those libraries and dependencies which were really posing a problem for us earlier. So into one logical entity, and this entity is known as container. And the process of like packaging this into one unit is known as containerizing the application. So this is one of the like most common used term, like let's well containerize the application and stuff like that. So just I wanted to make that clear. So it also gives us the capability to run like each service with its own dependencies and one isolated environment without posing any problem at all. So yeah, this is something that I wanted to discuss about. And since we have taken a quick overview about Docker, it would be great if we know and discuss about container as well, because finally we will be going to Kubernetes and where the containers are the soul. So let's consider and understand what are containers. So containers, as I have mentioned earlier, are the logical unit in which they have their isolated environments of their own, and they can like they have inbuilt dependencies as well as libraries, and they can be used to have one encapsulated process that could be used to run, and they could also have their own network interface as well as their own mount points. So it's similar to VMs. So we can like most beginners has this conception like yeah, we can it's a kind of a what do you say, an alternative to VMs, but make no mistake, it's not. So that's something I wanted to make clear also. So on this note, let's also discuss about some of the major differences between virtual machines as well as containers. By the way, these containers have made certain aspects of virtual machines very simplified and very easy to use, and that's why it has become so much popular nowadays. So on the right hand side, as you can see, you have two containers, and which are like which are running, and provided that you have Docker installed on your underlying OS system. So, and on the left hand side, you have two virtual machines. So virtual machine, as you might know, have their own operating system and are also packed with their own kernels, right? So we will be making those differences based on basically three form factors. So first one is the utilization. So to explain it, yeah, just you can look at the virtual machine, because virtual machine is very tightly coupled, right? So it has its own OS and all these components like libraries, application, and their dependencies, their libraries. So without a doubt, it goes like it consumes so much CPU as well as memory, and if compared to containers, yeah, they are comparatively less, the utilization aspect of things. And if you go towards the like size, so if I don't know how many of you have done, I know that that could be a significant factor. So if you have go over the web and try to install virtual machine, you must have come across various virtual images. So those images really have their considerable space, right? Very big one at that, like ranging from few 1 GB to 3 maybe. So this is really something which like not that portable, but yeah, it was it. But with Docker images, it was a complete game changer. For example, in the Docker community right now, we have image known as Alpine, which is 5 MB of size. And it's not like it's not used. It's used in the production system in so many organizations as well. So to just have a rough idea about how much size it consumes. Yeah, you can take that as an example. So third factor that I will be discussing about will be boot up time. So since virtual machine is tightly packed with so many components, it takes time to to have these component warm up, and hence it leads to a few minutes of boot up time, and that's why it takes a little bit time to have a virtual machine in a completely running state and serve whatever the users want. But whereas the containers takes only mere seconds to boot up, and yeah, to serve the kind of the applications that you want. So let's quickly come over to our next slide. And since we are talking about Docker and containers and images, there are two mainly uh, terminologies that we uses. So those are Docker containers and Docker images. So if you go over this, you'll see that Docker images and Docker containers is quite confusing for the beginners. So I would like to take this opportunity to explain it with an analogy of house blueprints. So you can use house blueprints. So well, many of you quite already know, right? So these house blueprints are used for like to specify where the doors should be and how much one room should occupy the space, as well as where the kitchen should be. So on that, this a single house blueprint could be used to create a number of houses. And if you go a little bit more deeper, if the families start to shift in, they have their own way of living, which ultimately gives the house a unique identity, their own identity. So just like that, the Docker images are like templates, a house blueprint, a plan, a package which has its own like packages, dependencies, and code needed to run the application and container. So you can use this Docker image to like spin up various containers on different machines, provided that yeah, Docker is installed on them. So you have rectified so many dependencies with just one, and that is Docker. So if you have Docker, you can do quite a much with that, right? So yeah, on that note, I will be like, it was a quick overview about Docker. And before diving into and learning about what I'm going to present in my demo, let's understand what I'm going to show you guys. So I will be using a voting application, and that application is going to be having two interfaces. One, the voting interface, which in which you can choose among like cats or dogs. You can vote for them, and then finally you'll have a resulting interface. This will show you the choice that you made in the real time, right? So this application is among the famous application which is used in Docker community, and this application is used to like really show the advantages of Docker, whatever Docker has to offer, right? So before diving deep into our demo, we will I would like to explain the architecture, how this application was, and how Docker transformed it for the better. So yeah, without further ado, let's see our monolithic applications which we were using earlier. Like we have one front end, and then databases and worker. So what happened is that all of them are built right as a single unit previously, and this is how applications were delivered in the past. So one of the major changes needed to be made to any of these components were like followed up with certain cross checks, and like if you want to do those changes, it could be the possibility was like the entire applications may have to be rebuilt and redeployed because of the dependencies between each other. So that was quite a downside for like the previous method of delivery and development of the software. So what it leads to, it leads to unsatisfied uh, developers. So finally, what Docker did, Docker, it gave you a way to modularize that monolithic application into as a diagram as you see on your screen, right? So this is also known as like microservices. So this modular entity, like the front end, the databases, and the worker as well, it decouples them. These applications will have their own like the dependencies and the libraries, as I mentioned in previous slides in them. So yeah, and one of the things is, since it is like modular, the development also becomes faster because they can be developed in parallel as well, right? So if you go and if you learn about them and if you see that these applications also have like a different combination of different services and different development tools and multiple development platforms, right? So like this application we can use and is used majorly all everywhere, right? So to show how what Docker has to offer. So finally, since we have looked at what microservices are, let's take a quick, let's finally go and see what Docker has to offer in real time, right? That is the Docker demo. So let's go quickly. And to for a demo purpose, I will be using a feature that KodeKloud offers. In here, you will see that there are multiple sandboxes that you can make use of. So for a demo, I will be making use of Docker Sandbox. So yeah, we will be using Docker Sandbox to deploy our application and using what really we can do with and what sorts of things that we can achieve with this. So it might take several seconds to completely come up. So yep. So yeah, you can also see like if you go, okay, my bad. Like if you go in here, you can see that this is the voting application that I will be using. It has like all the dependencies of file that you know explains what sort of dependencies should be there. So let's quickly run this. Yeah, if you go and if you see the Docker file, you will see that voting application and result, these are the front end, right? And if you go a bit low also, you can see the worker as well as our databases. So each block we have defined like the those I talked about, which ports needs to be opened and on what network we need this application on. Yeah, things like that. So each application has its like own block. So what we can do, yeah, by the way, the Docker Compose is just a wrapper around like you can specify blocks as shown to to spin up various containers at the same time. So yeah, we'll be using this one. So yeah, so what it will do, it will go on the Docker Hub and it will download the images and it will like spin up those containers as well. So for us, just one command was needed and that was it. So while it is like it takes several minutes to spin up and like so I will like quickly go over and show you guys what I meant by Docker Hub. Yeah. So if you go in here, I don't know if you can see. Yeah, we have many images regarding every applications out there. So if you go, you can see we have, if you want to learn about web servers, we have engines, we have like HTTPD. And if you go and if you want to learn about databases, then various alternatives are there, like MongoDB and MySQL. And if you are from a like programming background and you don't want all the things like installing IDE and all sorts of stuff, then you have Python image as well. And you are kind of a Linux kind of guy, you can also pull download the images of Ubuntu and then play around with it. So let's quickly go over. Let's suppose that we want to learn about a database. So what we will do, we'll go like MySQL. I think many of you know that it's a very good alternative if you want to learn databases. So I have copied this command, and I will paste it. So it will download this image, this MySQL image. So after downloading this image, what will happen is we have it locally. Right? If you see, we'll have MySQL image. So we can make use of this, and we can spin up one container using this. So I have one command already, typed out in the editor. So yeah, I can use, or maybe there's something wrong with this. Yeah, 1 second. So we can use something like this, and this will spin up one container for you guys. So yeah, that's how easy it is, to spin up one container. And if you like really want to learn, you can go inside this in this container, and you can log in into the command line interface, and finally you have MySQL command line. So you can use this to show how many databases are there. Yeah, let's just change to MySQL and see how many tables are there in this MySQL database. So there are considerably many, right? So yeah, like this we can make use of these containers to learn new stuff. And yeah, if you want, like I have spin up one container, right? So just to stop and uninstall, yeah, I don't want any clutter. Let's stop this MySQL container, and it takes one command only. So which is docker stop MySQL. So in the meantime, when I was showing you guys how to play with Docker containers, our application really got built, and yeah, I've seen that. Yeah, it's creating every component of our applications, like database and worker and voting and result application front end are deployed. So they are exposed at 5,000 port. Let's go, and yeah, we can see one is accessible, and the other one is also yep, you can see. So you have, as you can see, there is no votes yet. So if we go and if we click on cats, like I'm a cat person, right? So if you go and you will see a sudden shift of the vote, and yeah, it's depicted here in the real time. And if you change and revert back a vote, yeah, the vote will be reverted, right? So this is how easy it is to use the Docker, and to know spin up containers. And so yeah, it spin up around 5 components. So what if we want to don't want those that application now? So we can use this, and we can use one command like docker compose down, and that will take care of all of those things. The complexity is gone, and you have once again your environment free. So this was about the a quick demo of Docker. So yeah, let's go right back to our presentation. Okay, right. My bad. So that was the quick demo about Docker. So let's go. Yeah, now finally that we have understood what Docker does with the containers and how it really uses that technology to provide so many functionalities, let's take this opportunity to understand about container orchestration. So so far we have seen that Docker has so much to give to us. And why do we need why we need to orchestrate, right? So for that, let's take a case scenario and understand it using we have an application of Node.js, and you deployed one instance of it. So what happens, this application will serve a considerable number of users, right? And like just suppose that our applications become so popular, and that the traffic is increased by a great quantity. So what you do, you just go onto the machine and you run another command to create one more instance. And as the load increases, right? So you what you do, you manually run this like Docker run Node.js, which will create one more instance, and you do it multiple times. So it will create those containers for you. But then what will happen, if something, like as you can see the red one, right? If by some chance one container crashes due to some, yeah, unforeseen, like conditions, what we need to do, we need to find it manually, like where it has gone wrong, and we need to like replace it with a brand new one. Yeah, that is something we can do. But when we are talking about containers on a very large scale, like tens and thousands of containers, yeah, that's not a practical approach, is it? So what if now, if even the machine where we installed Docker goes kaboom? So yeah, the containers on that host system, they will stop working, right? And they will also like stop serving end users, and that is not at all what we wanted, and it's going to be a great nightmare for our application, right? So what alternatives do we have? So to name a few, we can also um, have a one dedicated engineer who can look after the performance and the health of these containers, as well as the underlying host, Docker host. And whenever there is some sort of issue, he just goes in there and removes and create different containers for that matter. And if we are like talking on a scale of like multiple nodes and multiple, too many containers, like thousands, 2000 containers, that is not a practical approach. And the engineer will also will be it will show unsatisfactory result, right? So that's where container orchestration come in. So it gives you a set of tools and scripts that can help you in hosting these containers in like any sort of environment, even the production environment, right? So you can use just like one command to host number of containers just with one single command. And you can also like have multiple Docker hosts. So what if one Docker host goes down? You will have others, right? You will have others that will keep on serving the end users. And yeah, that is kind of like the advantages, like where the container orchestration can be used. So the container orchestration have now, since we know this concept, we have different solutions for this. Like as you can see, like we have Docker Swarm. I think, yeah, some of you might have known this if you have some understanding of DevOps, So and then we have Kubernetes, where our final focus, right? And then Mesos. The Mesos is another solution from Apache. So let's first quickly discuss about Docker Swarm. So Docker Swarm is like very easy to install, and what it has, very simplified concepts. You can use it to, and you can also learn about it very quickly. But the functionalities aspect is quite limited, and that's why it didn't gain that much popularity, right? Whereas if you like consider Mesos is really very popular, and but there is quite a learning curve there, and a steep one at that. So if you go and if you try to learn, you build up and set up your environment for Mesos, then yeah, that hard work also pays off, because Mesos have so many great things to offer, and so many advanced features that it offers. But it was quite hard to learn, so that's why many of the people like finally choose Kubernetes also have like a kind of a great learning curve. But the at last, the features and the customizability that it offers, everything is worth it. So by the way, this Kubernetes project is backed by Google, so you will not have any problem with any compatibility or any issues for that matter, right? So let's go finally, right, to look upon a short overview about Kubernetes. So what we were doing earlier with the, as we have seen in the Docker demo, we run like one container and like MySQL, and it's easy. And that's what Docker does, right? To run a container. So what if we are talking about doing it on a scale? Like we have multiple Docker host, right? So and now what we need to deploy thousands of instances of our applications. So is it possible to do that? Yes, Kubernetes let you do that. And so with just one command, and you can run something like this, and you will have your, thousands of containers deployed just for you. And if you like, what if the users are still like pouring in, and you have more greater number of users? So that can also be managed, just one command, and you can scale it up just like that, 2000, right? So what now is this, like, if the users and like the load is ever like changing, this the like dynamic and unpredictable workloads are there. So if needs like this arises, we can use like auto scalers which can do it automatically for us. Yeah, that kind of functionality also exists in Kubernetes. Okay, so what if now we have like consider a different version, and we need to deploy it, right? So we can also do that using the command like set image, and that will deploy the next version, uh, just like that. So what if there is like uh, consider a bug in our applications which like nobody wants, right? So like we need to roll back as soon as possible. So what can be done, so we can run a command something like this, and which will roll back all of these things. So this was a very short kind of like what Kubernetes has to offer, and there are certain aspects as well like storage, networking, security. So there are certain out-of-the-box solutions with Kubernetes that are provided with it. But if you are not happy, and if you want to like extend its features, there are number of plugins for that. Number of plugins, right? And since I've talked about that, it's very popular. So like all the major cloud providers like GCP, Google Cloud Platform, or AWS or Azure, they support it out of the box. They have this offering. So now, since we have talked a lot about this, and let's just very quickly go over what like cluster means, and what sorts of components are installed where. So when we are talking about on scale, we have like different nodes, as in from the previous slide, as we discussed, like multiple Docker host. So in here, these host will like these Docker host will host applications, and that also on large scale, thousands of applications. So who will manage that, right?
Hello, your mic is on mute.
So is it
Yeah,
visible?
yeah, yeah. It's fine now, Mike. Yeah.
Hello.
Hello,
Yeah. Yeah. So should I?
hello, hello. Your mic is again on mute.
Hey, so is it audible now? Hey,
Yes, yes, yes. No, you are not audible.
yeah,
Yes.
okay. So, sorry for the inconvenience. I don't know what went wrong there. Yeah, so I was at the, you know, yes, in between. So let me know once you can see
Ye-
my
Yes,
slide.
yes, 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 yes. Your screen is now visible.
Yeah, thanks. So yeah, we were like on the topic like who really manages all these nodes, right? So yeah, that's where the master node come in. So that's where the master node come in. It looks at all the metrics of the nodes and health of all those containers. It looks after the life cycle of those containers. And yeah, master node is very crucial when we are talking about Kubernetes cluster. It has all the components like kube API server, scheduler, and controller plane. So yeah,
Hello. Sorry to interrupt, but your mic is again on mute.
I think someone is like being mischievous. Yeah. Okay, so is it audible now?
Yes, yes, yes. Now you are audible.
Okay, 1 second. So yeah, final we have kubectl utility. So we yeah it goes by many names: kube control, kubectl, and things like that. So we can use it to deploy yeah like various instances of our application, and we can use it to like query about the cluster info as well as like the nodes itself, and as I've mentioned, like deploy various a number of containers at the same time. So finally, let's hop on to our Kubernetes demo. And in this demo, uh, I will be making use of the same cloud offering that I talked about, KodeKloud. Uh, so we will be using Kubernetes sandbox. So in this Kubernetes sandbox, I will be deploying the same application, the voting application. So yeah, I since you have been already familiar with the architecture of the application, it won't be too much of anything. So for you guys to make this demo a quick one, I have already you know created one YAML file for this. So this is also like Docker Compose file. In here we have each block which is like dedicated to one component. Like for front end we have vote, for result we have another one, and things like that. So we can make use of this, and just with one single command we can like deploy a whole stack of application. So for the simplicity purpose, I am deploying only one one instance.
Hello. Your mic is again on mute. I think there is some technical issue from your side.
I don't know if somebody is doing that on purpose or it's an issue. So yeah, what I was talking about, yeah, it takes a little bit of time for these containers to spin up. So which you can see is like this. So still we have three containers in the container creating state, and yeah, things like that. So in the meantime, let me just quickly go over what like learning paths that we have for like every we have different learning paths like DevOps basics and Docker, Kubernetes, as as well as programming. So yeah, if you go over, you can start from the very basics and go over to the very advanced level. And if it suits your need, you have different like uh, you have different things like Docker learning path also, where you can start with the Docker basics and you can work your way to like for the certifications. You can also prepare for that. So now as we see, yeah, we have our application up running. Just one application also needs to be quickly say which port it is exposed to. So the same interface should be there as we are deploying the same application, right? So as you can see, we have the same the interface where you can choose like dogs or cats, and this will be reflected back in the real time. So this is something how easy Kubernetes also like makes it for like to deploy your application, and that too at a very large scale if you want. For the simplicity purpose, as I mentioned, I have done only one instance of our application stack. You can do many if you want that. So this was about Kubernetes demo. So let's go on, and yeah, like I have mentioned the learning paths that we had at KodeKloud. So you can choose any one of them, like DevOps Basics or Docker or Kubernetes for that matter. And after this session, you all guys will be provided with like a link for hackathon, which you can make use of. And it's kind of a coding competition, but for DevOps guys, if you're interested, and it will have three Kubernetes challenges as well. So we will be like giving $300 worth of vouchers and subscription. So yeah, please make use of this as much as you want, and the link will be open up to like 20th of March. So yeah, you can also give it like number of times, right? So yeah, that was it from my side for like the presentation point of view. And if you have any other questions, like just let me know.
Thank you, Dinesh, sir, for such an insightful information on this very overwhelming technology with us.
Yeah, my pleasure, Vishnu.
Yeah, so for doubts, I may like to ask you some.
Yeah, go
So
ahead.
first of all, I would like to ask, like, for DevOps purpose, if one is a beginner, then this new technology is very like ocean deep for
Yes,
like
yes,
beginner.
you're right.
Like it has very components like Kubernetes, Docker, and that components have several more components. So
Yeah.
a beginner might feel very new, matlab, very hard to learn. So what should be the roadmap, exact roadmap to start with it?
So to start with, like to even go into DevOps, it will be a very, if you know about a little bit of Docker, even before like going to any company, it will have a huge effect. You will have a like edge over others. So if you are asking about the roadmap, first of all, I will suggest you to get a basic understand, not basic, but yeah, workable understanding of Docker, and then you can move over to Kubernetes. And Kubernetes have like it's like you said, ocean deep. So it might take you like several months to understand what it has to offer. But if you are consistent enough, then definitely it's like one of the greatest technology that will definitely reaps good result in the future. So yeah, and by the way, if you are like wondering about the resources, I have mentioned about the courses. Like even if you go anywhere, And if you ask about Kubernetes, then you might find several courses which are de facto, and the names like Shadmanamand and several others comes up. So yeah, you search your way around web and you will definitely see many great courses out there.
Yeah, yeah. And what do you think are the prerequisites for one to start with DevOps? Like, what first know to start with DevOps?
So to start in like going into this, yeah, some understanding of Linux, a very basic one, and then like several tools like Git, source control management tool, right? And a very high level overview about how CI/CD works. You don't have to even like implement. You just have to know, yeah, how these like integrate with each other, and then like Docker, and then finally you can come to this. So all in all, you can start your way around like very basic Linux concepts, and then move on to Docker. So it might be a good idea to, yeah, go that way.
Cool, cool. And what do you think? Like everyone says, DevOps has many great opportunities out there, like in job terms and etc. So, what do you think exactly would be great in remote opportunities if one is looking for remote work? How DevOps can help him, and how
So if you give this, understanding and learning DevOps your considerable amount of time, you will see that there are, as you said, a lot of a lot of opportunities out there. And if you go and if you are confident enough in your skill set with this Docker, Kubernetes, and several other tools, you can really like enhance that can greatly enhance your resume. And when you like go for applying to any job, they will definitely help out. And as such, which I mentioned in the like at the starting, the report from Indeed, like these kind of scenarios are really like at the boom right now, the DevOps. So yeah, it might be like a very a great time for you to get into DevOps and yeah, learn your way around how things, yeah, work at a very high level.
yes, yes, good. If anyone has any doubts, you can post in the chat box, if you may like. We will wait for 2 minutes for doubts, and if not, then we will wrap up this meet.
Yeah, okay.
So I guess
You are on mute, Vishnu.
I guess we don't have any doubts as of now. Someone is asking the voucher for KodeKloud is valid for how much time?
Hello, am I audible?
Yeah, you are audible.
Yeah, it was me who was asking that question. Basically, you told that since 20th of March, that till 20th of March, we can access that voucher. So, is there a limit till when we can use the services of KodeKloud by using that voucher?
Yeah,
Yeah,
I guess that
can,
voucher is for 3 months. So
yeah.
Okay. Now, apart from this, it belongs to like development phase. If yeah, and if I'm not wrong, and Right now we are just tinkering with some basic stuff like DSA and all. So won't this be early for us to move with DevOps?
Uh, Divan Sugar, it's there's always a first step for everything, right? Even I also started with like DevOps in my final year of, you know, like a bachelor's degree. So it's not like you will face issues. Well, at first, everyone faces issues, but if you are consistent enough, then it will definitely help you out in long run. If you are like willing to, give it your time and things like that.
Okay, thank you, sir.
So, any other queries?
Okay, so I guess we can wrap up this very informative webinar. Thank you so much for joining and guiding us through the path of DevOps, Kubernetes, and all.
Yeah, thanks Vishnu for having me too. Right, it was really one exciting one experience for me. Okay, thanks.
Thank you, everyone.
Yeah, thank you so much for this
Thank you,
collaboration.
sir.